Hello, I would show you a short video about making a postprocessor file for my force axis in Powermill. Okay, short warning, if you make your own file, please check it carefully and test it also carefully, otherwise it can damage your machine. So the first step is to make a cut file for the postprocessor editor, so you can easily change the code. For that we have to make a few toolpaths, like here, and insert the toolpaths in the NC file. And for the cut file we go to the NC program task. We have to select our NC file and go to the options. The name, yes, and we have to change the options to cutter location. This is where I save the cut file and write it. So now I have a cut file. So after making the cut file, I go to the Autodesk Manufacturing postprocessor utility and load the generic Fanuc postprocessor, which comes in the package. Okay, this postprocessor is save as under my project folder. So I can edit it. Okay. Now the first steps are the option files settings. Okay. On the initialization tab I have to add a few things. The arc mode is okay. The high speed mode I delete. Program end is okay. Tool loading is okay. And tool charge. Yes. Okay. Here I enter 0.1. For the Linuxcnc file I need the ending in GC. I don't want to split any NC program. Okay, this is good. So My inverse time settings speed is maximum 3000. Okay, I had to define my machine kinematics first. 4-axis stable. The directions from the rotor is okay. This is okay, and this is for me also okay. Here at the view, you can see my A-axis is on the X-axis, my Y-axis and my Z-axis. This is okay. So now I can change inverse time to yes. Okay, the maximum cutting feed is 5000. My rapid feed is 8000. My spindle speed is 8500. I can splice. And the axis I do on XY. Okay. And calculation. Okay. Canned cycles. Linuxcnc supports a few canned cycles, but I need only the rigid tapping cycle and nothing else. Because when you go to Powermill and to drilling, you can check the cycles or not. So you can generate your NC code without cycles, but not at the rigid tapping. There is a cycle checked, and you can change it. So we need here in our supported cycles the rigid tapping cycle. Yes. Okay. Never. Check yes. Minimize rotations, yes. Okay. So turn up. Now the debug view. Machine kinematics, we have already done this. Then format. Okay, general, this is okay. The case uppers is okay. Blocks. Linuxcnc doesn't need any block number, so we set this to no. Okay, but the block item separator we doing a space hit. Okay, and C comments, yes, substitutions, and string values. Close. So after we controlled and edited the option file, we can now test to load our cut file. Here it is, 4-axis cut. And we try to process it. Trust this file, yes. Okay, this is how the and see how it looks like now. It has to be a little bit updated. Okay, there are a few warnings. The cutter compensation mode we have to set to read and write. So we go to the cutter compensation mode and allow change. Yes. So we don't get this error anymore. Now process it again. And the error is gone. Okay, now we see we don't have an A-axis written in the code. This will change now. Okay, so we have to go to the editor and to the commands. For the A-axis move, we change the rapid and enter the following. So parameter Diycnc 1 and feed reads. In the Diycnc 1 we set the prefix to A, output to tape if updated. Okay. So we set to minus 360 and 360. Default command. As a parameter, and we set this to A. So now we see here the code how it looks like for the rapid move. The same we do in the linear move. So I'll copy this, go to linear move, and fill it in. I don't need the cutter compensation. And there are also no cutter compensation. Okay, so here looks like the code. Okay, so now we try to process our cut fill again. Okay. So okay, I had to reload the cut file, and now we can process it and we see the A-axis is here. So we can also add the processor debug file. Okay, delete it, unload and load it. Okay. Okay, now we see the NC code. I try it once again with the fan, debug. Okay, so now I have the debug file. There you can see in which categories the NC code is split. And when I double click here, I can directly change into the editing tool in the editor. So now let's edit the program start. Okay, we don't need a program number in Linuxcnc, also I don't need one, so I delete this. Also this. Okay. This. So. Okay, here's my tool list. Here's the sample text. Okay, good. So output doing set none. Put the compensation. Okay. I also need run. Okay. Okay. And go home. Okay, now we do the toolpath start. Okay, motion happen. I moved my position my rotor axis here. And update it. Okay. Then G43 for the tool length. Okay. Current mode. Okay. And we don't have a high speed setting here. So now to the controller switches. Okay, get the compensation off. I let it. The coolant I insert was deactivated. block number, current mode, change years. Here you see the current modes. For Linuxcnc, M09 is the deactivation. Okay, and by current off, I have to do the same. Okay. For example, M007 for mixed cooling and M09 for coolant off. Okay. Okay, spin on. Okay. Spin off. It's also okay. Okay, now we go to the moves. Okay, so we changed the move rapid with the rotary axis and the move linear also with the rotary axis, and now I want to my G93 and G94. So the inverse time activation, deactivation. This can be done with the rotation on and rotation off. So for rotation on, insert the condition, the block with the axis and the block with feed mode. The feed mode I have to edit and set. The value to explicit and the value 2 per minute. Oh, sorry, the inverse time. The rotary on. So I see on the sample the G93. Don't forget to save. And the rotation off. I do the same. And the rotary is working. I want feed mode. Explicit value per minute. G94 we see here in the example. Okay, now we switch to the tools. Load tool first. Yeah, it seems okay to me. Load tool, also okay. And unload tool, coolant off, spindle off, and go to G53, 0. It's okay. Okay, so now we go to the cycles. Okay, moving cycle, we don't need this dwelling cycle and okay. Okay. Dwelling cycle start. We don't need this. The rigid tapping setup. Okay. For Linuxcnc we need the G63.1. Split pitch. So the total depth and the third pitch. This is Linuxcnc K. So that was it for the rigid tapping setup. Okay, so now let's move on. At the axe, I only need the color move in the XY plane. So deactivate this and this, and the helical moves and leave it. Okay, now the backplane signal standard I will activate. Okay, it will set. Bring the toolpath header, yes, and the dwell. When you do dwelling, you can set the dwell time. When the dwell stays at a location a few seconds. In Linuxcnc, this is done by G4. So as a block, G4, and here I set the dwell time. So I can, when I do dwelling, I can set here the dwell time. Genau. And I have to activate G4. Prefix I need to Linuxcnc P00. Oh, I forgot something really important. And at the tool start, you can insert the tolerance. So make a new block and the parameter CL data tolerance. Okay. Here I said specify G64 P and Q for the Q value. So now I have here my G64 tolerance data. So now I think this was it. With my toolpath end, yes, it's okay. And program end, and I delete the RN. I don't need it. Okay. And save. So now we try to unload our cut file and load it again and process it. So this is now the NC code looks like. So we have the tool change, we have the spindle speed, the cooling, okay, now the tool length compensation with the tool number, tolerance, and the G93 for the inverse time until the toolpath ends. G94. You see, until the toolpath ends, then we have the G94, and after that we have the linear movement, then we have the multi-axis movement with G93, and so on. And I think we have also the G33.1 for rigid taping. Yes, here at the end you can see the tool number 17, Powermill, tool number 17, and the G33.1. with a tolerance of 0.1. And the tolerance I can change when I do the feature sets. But in the normal strategy, I can set the tolerance here, 0.01, and I can find it here. Swarf toolpath with the tolerance 0.01. So now let's see if the postprocessor is working. Here's the new Linux post, which we done before, which we've done before. Okay, now we need the NC program. Okay, and retest it. So it looks like good. Okay. So here we have it. Let's see how it looks in the backplot. It looks good. Okay, now we try to simulate it. Okay. Okay, I disabled the toolpaths and I try how it's working. So it looks good to me. Okay, that was it. Thanks for attention. See you next time.